everyone. In our environment, you make use of approximations and then you make use of rounding because most of the time you encounter errors in major calculations in day-to-day life. So we often have to approximate and round things off. Now, in this video, I'm going to be talking about approximation, rounding, and errors. My name is Anthony Nathaniel, and I welcome you to this next episode. Now, let's start with approximation. Approximation is when you make a number from its original value, change it to a value that is closer to its original value. So the approximated value is often closer to the original value, but is not the exact value. So most often in mathematics, even in various parts of mathematics, including calculus, statistics, we make use of a lot of approximations. For example, when we are looking for the volume of an area on a curve, when you get to other parts of mathematics in the advanced part of mathematics, when we get to the third series of this course, we are going to be dealing with that in mathematics for SS3. So, but in this SS2 part, whenever you're getting the area of the curve, you are making use of approximations. So, and then everything in mathematics is one approximation or the other, because mathematical figures are often too large, too big, and they are often too lengthy for us to take them down all at once. So we'll make use of approximations. For example, let's do some approximation. Let's approximate 163.864. Let's approximate 163.864 to two decimal places. So if you want to do that, that would be, you look for the two decimal places. These are the two decimal places, 8 and 6. Then the number before them, which is 4, you round it up or down. So if it is 5 or above, 5 and above, you round it up. But if it is otherwise, or rather if it is below 5, you round it down. So this 4 is below 5, right? We round it down to 0, and then we'll add it to the second decimal place, because we have to calculate to two decimal places, right? So now that will be 163 points. Now when we round 4 down, that will be 0.86. These two decimal place. Now next we have to find the value to one decimal place. So to one decimal place, we are going to look for the first decimal place and round the second number down. So in essence, we are going to be rounding this 8 down. That will be 163 point. This is the first decimal number, right? So we are going to round the number before it, which is 6. We'll round it up. That will be 7, 8. That will be 9. 163.9. Then the next one we have to round it to the nearest whole number. So, but basically these are the whole numbers, 163. So basically you just round the numbers before the number directly before that, which is 8, before the whole number. You round it up or down. So in this case we're rounding it up because it is up to 5 and even greater than 5. So that will be, we'll round it up to 1 and add it to the last digit of what we are going to. That will be 3. We'll add it to 3. That will be 164. So that's how to round and approximate numbers. So you can even mess around with other questions and deal with them. But now let's talk about estimation. Estimation is basically just like approximation, but when you estimate a number, depending on the number of significant figures, so that is known as estimation. So when we make estimates, we are making use of rough values. For example, if I'm asked to look what's the value of 1.9 times 2.1, I can roughly say that 1.9 is I can estimate it to be 2, and then I can estimate 2.1 to be 2. So that my estimated value will be 4. So, and if you get your answer, this is 1.9 times 2.1, your final answer should be close to 4. So estimations are used in mathematics when the procedure of calculation is too tedious and lengthy. We make use of estimations to get a general overview of how our answer will be. And secondly, you also use estimations in order to predict whether your answers are right or wrong. So for example, if I say 1.9 times 2.1 is 7, so and I've estimated my answer to be 4. If there's too much deviation from my estimation, then my answer is wrong. So that is how to predict whether an answer is correct or not, using estimations and rounding off. So now let's go to the next part of this video, which is the main part, where we're talking about errors and percentages. So the error, it is the difference or the deviation from the actual value to the estimated value. So that is simply what error is. Then whenever you are looking for percentage error, you convert your error to percentage. That's known as your percentage error. Let me give an example. A square is 5 cm by 5 cm. Now a student measures the side of the square as 4.9 cm. She uses her measurement to calculate the area of the square. Find the percentage error in the length of the side. and the area of the site. So there are two sub questions here. We have to find the percentage error in the length and percentage error in the area. Now the percentage error in the length is the estimated value divided by the true value times 100%. That's the percentage error. But if we have to look for only the error, we'll just look for the estimated value. Now the percentage error of what? The estimated value is 4.9. So the error will be what? Error will be 5 minus 4.9 divided by the true value, which is 5 times 100%. So if you are wondering how I got this is the formula for percentage error. Percentage error is given by error over true value times 100%. And the error itself is given by what? True value minus estimated value. So the error is equal to true value minus estimated value. So when you calculate this, you are going to get the error, which in this case is minus 2%. So error is actually estimated value minus true value instead. Estimated value minus true value. So this is 4.9 minus 5. So we'll get a negative answer here, 4.9 minus 5. So this negative value denotes that our calculated value is less than our true value. So if you see an error of 2%, you can even predict the magnitude and direction of your error. Because the reason why I said direction, I'm not trying to say it's a vector, but this negative symbol shows that it is a deviation in the negative direction. So but if it's only 2, we'll know that it is a deviation in the positive direction. That is the direction of the error, not in terms of vectors this time around. Now that's simply what it is. Then let's talk about accuracy. Now this accuracy is just dealing with the fact that the number of significant figures of your answer must not be greater than the number of significant figures of your question. That's simply what it means. So for example, if my question is given to one significant figure, then my answer must also be in one significant figure. For example, if you have to calculate the area of a circle of radius 3.5 centimeter, and then your radius is given in two significant figures, which is 3.5. So your answer will also be given in 2 significant figures, which will be approximately 38. So in mathematics, it is good practice never to give your answer in significant figure that is more than your significant figure for a question. So thank you for watching, and see you next episode.